Hello dear students. We shall discuss a topic from Module 5 of Embedded System. For today's discussion, the contents for today's discussion is concept of semaphore, use of semaphore, types and comparison of binary and counting semaphore and its functions. Let's start with semaphore. Semaphore is nothing but a synchronizing tool. Semaphore is nothing but a synchronizing tool with the help of which we can ensure that a critical section can be accessed by the processes in a mutually exclusive way. So, the processes will try to enter into a critical section. So, this particular synchronizing tool, semaphore, will ensure that at a time only one process can enter into a critical section in a mutually exclusive way. If we want to go into the details, semaphore is nothing but an integer variable. So, on a semaphore, we can perform two atomic operations. One is wait and the other one is a signal. What is the meaning of atomic operation? Atomic means operation, either the full code will get executed on that particular semaphore variable or will not get executed. That means partial execution of the wait code or signal code will not be executed. Either they will be executed totally or will not be executed. Or in other words, a semaphore controls access to a shared resource through the use of a counter. A semaphore controls the access to a shared resource through the use of a counter. If the counter is greater than 0, then access is allowed. If it is 0 or less than 0, the access is denied. The value of a semaphore is a non-negative integer. Now I explain the concept of semaphore with the help of a flowchart. This explains how a semaphore can be used. Initially, a semaphore is created with initial value of count. The thread that wants access to the shared resource tries to acquire a permit. If the semaphore's count is greater than 0, then the thread acquires a permit. That is, now the semaphore provides an access to shared resource to the thread. After acquiring the permit, the semaphore count will get decremented. If the count is less than or equal to 0, the thread will not get access to the resource. That is, the thread will be blocked until a permit can be acquired. When the thread no longer needs an access to the shared resource, it releases the permit, which causes the semaphore count to be incremented. If there is another thread or a process waiting for a permit, then that thread or a process will acquire a permit at that time. I can explain this concept with an example. Consider a situation where there are two persons who want to share a bike. Considering a situation where there are two persons who want to share a bike. At one time, only one person can use the bike. The one who has the bike key will get the chance to use it. And when this person gives the key to the second person, then only the second person can use the bike. In this example, semaphore is just like this key. And the bike is the shared resource. And the two persons are the two processes or two threads or two tasks. Now we'll see the use of semaphore. Apart from managing shared resources, task synchronization can be performed with the help of a semaphore. In this case, semaphore will be like a flag, not key. Now we'll see the types of semaphore. There are two types of semaphore, that is binary semaphore and the second one is counting semaphore. Now we will see the binary semaphore. Already I have mentioned that The semaphore is a non-negative integer value. So if the integer data is allowed to take only the values 0 and 1, then this type of semaphore is called as binary semaphore. Let me say once again, if the integer data is allowed to take only the values 0 and 1, then this type of semaphore is called as binary semaphore. Binary semaphore exists in two states, acquired, and the second one it is released. And it allows, the binary semaphore allows only one process to access the shared resource. In binary semaphore, a process waits to access the resource. It performs wait operation on the semaphore and decrements the value of semaphore from 1 to 0. When it releases the resource, it performs a signal operation on the semaphore and increments the semaphore value to 1. If the value of semaphore is 0 and a process wants to access the resource, it performs wait operation and block itself till the current process utilizing the resources release the resource. Binary semaphore is used when there is only one shared resource. Now we'll move on to counting semaphore. So counting to handle more than one shared resource of the same type, counting semaphore is used. That is, to handle more than one shared resource, counting semaphore is used. Counting semaphore, it is an unsigned or signed integer that can be taken till its value equal to 0 and is initialized to a high value. It can also be given a number of times. Semaphore variable s in semaphore function increments when s is released, posted or given, and decrements when the counting semaphore is taken, accepted or received. Now we'll see the comparison of binary and counting semaphore. So in binary semaphore is mutual exclusion mechanism is involved in binary semaphore. That is, at a time only one process can share the resource or can use the resource. In counting semaphore, no mutual exclusion. So in binary semaphore can take only value 0 and 1, but a counting semaphore can take any integer value. So in binary only one slot, counting more than one slot. So that is the main difference of binary and counting semaphore. Now we will see mutex or mutex semaphore. It is somewhat similar to binary semaphore. Mutex is a mutually exclusion object. It is not a synchronizing tool but a locking tool. So mutex is not a synchronizing tool but a locking tool. So as I said that a mutual exclusion, mutex is a mutual exclusion object, is a program object that allows multiple program threads to share the same resource such as file access but not simultaneously. Let me say once again, a mutually exclusion object, that is mutex, is a program object that allows multiple program threads to share the same resource such as file access but not simultaneously. When the program is started, a mutex is created with a unique name. After this stage, any thread that needs a resource must lock the mutex from other threads while it is using the resource. The mutex is set to unlock when the data is no longer needed or the routine is finished. Therefore, mutex is a locking tool but not a synchronizing tool. Now we'll see the Semaphore IPC functions. So these are some of the Semaphore IPC functions, that is semaphore create, semaphore post, semaphore pend, semaphore accept, semaphore query. So first we'll see semaphore create. This create function is used to create a semaphore in an event control block and also initialize the semaphore with an initial value. That is, creating the semaphore and initializing the semaphore, we are using create function. Now the next one is semaphore post function. OS, operating system, sempost. This post function signals a semaphore. So that is, a task can use this function to signal the availability of a semaphore to any other task awaiting for the same semaphore. Let me say once again, a task can use this function to signal the availability of a semaphore to any other task waiting for the same semaphore. The count associated with the semaphore is incremented by 1 and the access is granted to the highest priority task waiting for the semaphore. Now the next one is semaphore pent. This function is used by the task for acquiring a semaphore. This function is used by the task for acquiring a semaphore. The availability of semaphore is signified if the count associated with the semaphore is greater than 0. If the semaphore is available, that means if the count is greater than 0, then the access is granted to the task calling the function and the count is decremented by 1. If the semaphore is not available, then the task is blocked and it is put in the semaphore wait queue list. The task can wait till the semaphore becomes available or till a timeout occurs. Now we'll move on to accept. This function which reads and returns the present semaphore value. A return value of 0 indicates that the semaphore is not available. A non-zero value indicates that the semaphore is available. Next is query. It is used to obtain the internal data of semaphore structure. It is used to obtain the internal data of semaphore structure. That is, the function queries the semaphore for an event occurrence or non-occurrence by reading its value and return the present semaphore value. Let me say once again, this function queries the semaphore for an event occurrence or non-occurrence by reading its value and return the present semaphore value. The semaphore value does not decrease. Now we will see the function or how we can use a semaphore between A and B. So here it has shown two tasks, task A and task B, sharing a same resource. So here they have taken 5 states, that is T0, T1, T2, T3 and T4. So initially there is a notification of request to take semaphore has come from task A. There is a notification of request to take semaphore has occurred from task A at T0. That you can see over there, T0. After the notification or after the request, immediately the operating system block task B. Task B also requires the same resource. So task B is gone into the blocking state at T1. At T2 state, take the semaphore flag into at T2 stage, they're taking the semaphore flag by task A. After releasing or after finishing the operations or need of that resource, task A is releasing the semaphore at T3. Once task A has released its semaphore or has completed its operation at T4th state, task B can share the resource or can use the resource. That's what they have shown in this diagram. That's all regarding the different types of semaphores and the concept of a semaphore. I hope you understood that. Thank you very much.